Alright, this is a quick review of Trig, just in case you need it. So I've placed on here already the 3 different triangles that we are going to typically see, the ones that you should either have down in your notes or pretty much have memorized at this point, because these give you ratios that you can always have, and since they're pretty much split up the main 90-degree triangle, it's very, very helpful even estimating what the actual answers are for other little bit more specific degrees. When we add cosine, sine, and tangent, that's just going to tell us what sides to pick for our ratio. So at this moment, if you don't already have it, make sure these get down in your notes right now. So for all triangles, including this really weird 90-degree one here that I attempted to draw, then the cosine, sine, and tangent tells us the ratio of whatever angle is given to us here. So assuming that, let's say this is 67 degrees, then I can punch in my calculator, and my calculator will tell me what the ratio is of these particular sides. So let's say I want this side, and I already know that this side over here is 20. What I'm asking my calculator to do once I punch in sine, cosine, or tangent is tell me what the ratio is, again, of these sides. Because it's adjacent and a hypotenuse, I know that I need to use the cosine. The cosine of 67 degrees will tell me the ratio here, and I'll set that equal to the ratio of x over 20. This sets up actually a fairly basic cross multiplication problem. So the cosine of 67 is 0.391. Or in other words, this side is 39.1% of whatever's over here to the one side of 20 degrees. So cosine always tells me what fraction of the hypotenuse is right here on the x. And so that's entirely what we're trying to do right here. So you multiply the 20 over times the original ratio. That's 39. Misdid that. That's 39.1% of 20, as you can see right here, is going to give me x. And so that tells me that x is 7.81. Now let's transition this right here into vectors. In a vector, when you're given an xy axis, this is actually a vector right here. You're going to be given the magnitude of a vector, say, let's go 43 meters, and then you'll be given an angle of a vector, let's say, I don't know, 54 degrees. What you're going to do with that is just like normally, you're going to write that 54 degrees right here. The 43 meters is going to go here, and this starts setting up a terrible, terrible triangle. Now cosine will always give you the x so long as angle is measured from the x-axis. You can see right here that if the angle was in fact measured from the opposite way, from the y-axis, I can still create this triangle, but in that case cosine, or the adjacent side, will actually give me my y, and then sine, or the opposite, will give me my x in that case. For most of our problems here, though, the angle will be measured from the x, and therefore cosine will be x and sine will be y. It's good to point that out because later it will be useful, of course, to measure this other angle and find the x and the y that way.